All right, chemistry, we're on to lesson 6, and this is on significant figures. So first we need to cover the topic of rounding, which I think you're all familiar with. Rounding is a process of limiting the number of digits after a decimal point, or it could be before a decimal point, actually. Round the following number to 3 significant figures. So the significant figures are the first 3 digits you see there, 3, 4, and 7. So how would you round that number? This is 3 significant figures. So if the next digit to the right, which is a 6, if that's less than 5, then the 7 will stay as a 7. If that next digit, the 6, is 5 or greater, the 7 will round up to 8. And as you can see, it is greater than 5. So that means the number will be rounded to 3.48. Significant figures, which we usually just refer to as Sig Fig, indicate the precision of a measurement. In math terms, they provide a set of rules for how many digits you should use in your answer based on the precision of your laboratory measurements. So here's a room that we measured, and you measure the width of the room with a very precision laser device that's precise to 1/10,000th of a meter, and you get the width as 5.2143. Then the length of the room you measure with an old meter stick, and you measure it less precisely to 8.1 meters. To obtain the area, you would use the formula area equals width times length, 8.1 times 5.2143, and you get 42.23583 square meters. Significant figures indicate the precision of a measurement. So this value of 42.23583 indicates a level of precision for the measurement that is misleading, because the length measurement could have actually been anywhere between 8.05 and 8.14 with rounding. Either of those numbers would round to 8.1. This means that the area could have ranged anywhere between 41.975 and 42.444. So that's a half a square meter difference. The rules of significant figures limit the number of digits you can use in the answer to 2. So there's the answer to the correct number of significant figures, 42 square meters. So how did we arrive at that number? Here are the rules for significant figures. Non-zero digits are always significant. That's numbers like 1, 2, 3, 4. Leading zeros are never significant. Zeros between non-zero digits are always significant. If there's a decimal, trailing zeros are significant. If there's no decimal, trailing zeros are not significant. And finally, the last one we'll save until we get to the question that deals with that. So let's see some examples and it will make it clearer. So let's look at this number. Non-zero digits are always significant, so 4, 3, and 8 are always significant. Leading zeros, those zeros in front, are never significant. Zeros between non-zero digits are always significant. And trailing zeros, zeros that come at the end, are significant if there is a decimal, and there is a decimal. So how many significant figures? That would be 8. Trailing zeros without a decimal will not be considered significant. So how many significant figures is this number? 1 significant figure. So let's look at some examples here. 326. How many? What I'm asking is how many significant figures? There's 3 significant figures. All non-zero digits are significant. 3045. 4 significant figures. A 0 between non-zero digits is significant. 6020. 3 significant figures. No decimal, so the trailing 0 on the right is not significant, or some books would say it's uncertain. How about this one? 5 significant figures. Leading zeros are never significant. How about this one? 1 significant figure. Trailing zeros are not significant or uncertain if no decimal point exists. This one? That's 5 significant figures. The decimal point makes the trailing 0 significant. It may be unusual to see a decimal like that with nothing behind it, but it is written, and sometimes it's written for exactly this purpose, to indicate that those zeros are significant. And this one, 4 significant figures. Leading zeros left of the 1 are not significant. Trailing zeros to the right of 1 are, because there's a decimal. Let's try some multiplication. So here's the rule for multiplication. The product should contain the same number of significant figures as the multiplicand. That's the two numbers that are being multiplied with the least significant figures. So this is really the main rule you're going to use in this class all year. Maybe 98% of the time, this is the rule you're going to use. So value. So 2 times 4 equals 8. That's what your calculator would tell you. So how many significant figures? What is the significant figure answer? Well, first, how many? There can only be one significant figure because 2 and 4 have only one. So that's the significant figure answer, 8. 2 and 4 have one sig fig, so the answer has one sig fig. How about this? 31 times 23 gives you 713 on your calculator. Now this is a tricky one, and this is the one that I'm going to go back and show you the rule on. 710. That's tricky. So how many significant figures can the answer have? It can have 2, because 31 and 23 have 2. Okay, and here's the 6th rule that I didn't show you earlier. The final sig fig answer must have the same number of digits to the left of the decimal point as the calculator answer, with non-sig fig digits represented as zeros in terms of this problem. Okay, so the calculator answer is 713. We know that the final answer can only have 2 significant figures. That would be the 7 and the 1. But that third digit, that's to the left of the decimal. You don't see the decimal, but there's an implied decimal point behind the 3. You have to fill that in. You can't just make that digit disappear. Since it's not significant, it has to be a 0. So 7 is significant, 1 is significant, the 3 is not significant because the answer can only have 2 sig fig, so you fill it in with a 0. So let's read this. Each of the multiplicands has 2 sig fig, so the answer is limited to 2 sig fig. The last digit, 3, should be rounded down to a 0. Okay, let's try these two. There's the calculator answer. So the sig fig answer is going to be 0.34. Why? Because 3.3 has 2 significant figures. So 0.104 has 3 sig fig, and 3.3 has 2 sig fig, so the answer is limited to 2 sig fig, and the answer is rounded down to 0.34. 314 and 0.204 both have 3 sig fig. There's the calculator answer. So what's the sig figs are going to be the 6, the 4, and that 0, but it's going to get rounded up to a 1. So there it is right there. So each of the multiplicands has 3 sig fig, so the answer is limited to 3 sig fig. The 5 rounds the 0 up to a 1. Okay, how about this one? All right, 1 sig fig in the answer. So think about that tricky problem you saw just a minute ago. So how many sig fig can the answer have? Only 1. But what do you do with those other 4 digits? They can't just disappear because they're to the left of the decimal. So the answer is 40,000. The 5 limits the answer to 1 sig fig. The 2 is rounded down to a 0, and all remaining digits are zeros. Division works the same way. The divisor or dividend with the least number of sig figs limits the answer. So this one, you see 2 sig figs in the denominator, 2.8. So you do that division. That means the answer can have 2 sig figs, 1.1, and the 5 rounds that second one up to a 2. So 2 digits in the denominator set the answer at 2 sig fig. 3,400 is 2. 987 is 3. So you can have 2 in the answer. That's going to be 3.4. The second 4 rounds the first 4 back down to a 4. So 3,400 has no decimal and has 2 sig fig. 987 has 3 sig fig, so the answer has 2 sig fig. Okay, 0.8's got 1 sig fig. 0.00314 has 3, so the answer can have 1. So again, this is one of those tricky ones. What's it going to be? The only sig fig can be that very first 2. That means the other 2 digits, the 3 and the 4, have to go to zeros because you have to have 3 digits to the left of the decimal. So it's going to be 200. Okay, there's the explanation. The rules for addition and subtraction are different than multiplication and division. So the rules are: line up the decimals to add, subtract numbers. The sig figs are determined by the number with the least number of digits after the decimal place. So let's just see what that means. You want to add those 2 numbers. So you put the number with the least number of digits after the decimal is 23.45. So you draw a red line right there and you just add the numbers. And you get this. So this answer is going to have 4 sig fig: the 2, the 9, the 1, and the 8. The 6 is going to round the 8 up to a 9, so the answer is going to be 29.19. Okay, that takes care of our lessons. A little bit of a longer lesson, but I'm going to tell you that the only situations almost that you'll use in this class is multiplications and divisions. So everything else is just for knowledge, and maybe you run into it, but multiplication, division is, and they're pretty easy to do.